Welcome to our IVJ channel. In this class, we discuss about oscillatory motion. Oscillatory motion definition. So first of all, write the definition of oscillatory motion. So the to and fro motion of a body about its equilibrium position or mean position is called oscillatory motion. Example I am taking. Now this is an object. Now this is suppose it is hanged. Now just I am moving, I am pulling this towards my right side. If I leave this, this is called extreme position. If I leave this one, if it reaches to mean position, this is called, and if it moves to other side, so that is called extreme position. Again it come back to mean position, again come back to extreme position. So here from this position to the other extreme side, so from one extreme position to other extreme position, that is called to motion. So from the other extreme position to this starting or initial extreme position, that is called fro motion. So the to and fro motion, one to motion and one fro motion together called one oscillation. So what is oscillatory motion? So the to and fro motion, the to and fro motion of a particle or a body about its mean position, about its mean position is called, mean position is called oscillatory motion. Oscillatory motion. So here 1 2 plus 1 fro motion is equal to 1 oscillation, is equal to 1 oscillation. Now what I am doing here, I am here what I am doing, so take a example, wall clock. The oscillations made by a oscillations made by the oscillator in a wall clock, and the motion of the wall clock, the motion of the wall clock is called oscillatory motion, is called oscillatory motion. Example, so I am taking a wall clock, suppose this is the wall clock. Okay, now it is fixed to a rigid support, let it be. Now this moves towards one side, let it be, I am drawing in a simple way. Now see here, this is called simple harmonic oscillator. Now what is this one? This is a string, weightless string. This is called bob. This is called bob, metallic bob, metallic bob. Now this is a string, its length, let it be O, this is a position M, suppose at moves up to this position, let it be B. It moves this side position, let it be A. So here OA, OB are the extreme positions. OA, OB are the extreme positions. OA, OB are the extreme positions. Now see here, this is the length of the up to here. This is center of the bob. Up to here from position O up to here, this is the length of the simple pendulum. What is this one? Simple pendulum. Simple pendulum. Now this is extreme position. This is a extreme position, and this is also extreme position. Now what about this? This is called mean position, or here this is mean position or equilibrium position. Mean or equilibrium position. Now this is called rigid support. Rigid support. So it is moving from OA. If initially it is at position OM. OM is called mean position. Initially at rest. So it is called rest position initially. But actually there are two forces acting on that pendulum. One force acting towards the point O, rigid support. Another one towards the ground, acceleration, gravitation force. One force, another one tension towards the O. This is called tension T, O. Okay, now I am pulling this metal gear towards OA, this position OA. Now let it be initial position. If I leave it, automatically it reaches to B. How it will be moved? It reaches from A to M, and again come back to, it goes to B, OB. So this motion is called two motion. This is called two motion. Now it come back. Okay, here whenever it is moving from OA to OB, OA to OM, some force will act on this bob. See, I will explain clearly. Now first, if OA, it is at position OA, I leave it, automatically it reaches to position B, OB, extreme position. Again that motion is called two motion. Okay, now again after leaving this one, or if we want to touch it, automatically it come back to its position A, OA. Now that is called fro motion. So two motion plus one fro motion is called one oscillation. So this is about one oscillation. One oscillation. Okay, this is about okay. Now what is happening in this case? We go into depth. So here, whenever it reaches to A, what we are doing? We are pulling the bob from position OM to OA. That means we are applying some force on the bob to reach, or on the pendulum to reach position OA. That is nothing but extreme position. So that force into displacement. So if you draw here shortest distance from the bob to the center, from the center of bob to the OM, automatically the shortest distance nothing but displacement. Let it be S. So force into displacement is nothing but energy. Work is, force into displacement is nothing but work. This work is stored as energy, potential energy. So here this energy is gained by the simple harmonic oscillator when it is at extreme position. Okay, na? And so if I leave this, automatically some force acts on the simple pendulum towards the OM, means mean position. So what is happening here? Some force acts or tend to acts on the simple pendulum tend towards the mean position or equilibrium position. That force is called restoring force. That force is called restoring force. So what is restoring force? Ikkada newly one force we got here. What is restoring force? Whenever the simple pendulum is at extreme position and on leaving the external force or on releasing that or on without support, or means if we leave it, means without applying any force, automatically it reaches to main position or equal. Again it come back, it go to other extreme position. Means some force acts on the simple pendulum to move towards the mean position. That force is called restoring force. That is also called torque. See, whatever the force I am telling, force, the force or torque acts on the pendulum or on the body, whatever it may be, on the body to move on the body to move towards the mean position. The mean position is called restoring force. Body BOD by Prasad. So some force acts on the body whenever to move towards the mean position is called restoring force. Okay. Now, due to the restoring, here what is happening, how it will be varied. Here, whenever it is reaching from OA to OM, the restoring force will gradually decreases. Because, see here, whenever it is trying to move towards from OA to OM, automatically some force acts opposite to the restoring force. Some force, okay. That force is called resistive force. So here how many forces are acting? Two forces are acting on the simple oscillator, simple harmonic oscillator. One is restoring force. This force acts on the simple harmonic oscillator, tends to move towards the equilibrium position. That is called restoring force. And that actually whenever it is moving from OA to extreme position to mean position, gradually decreases. Up to here increase, from OA to OM increases. Restoring force increases. Restoring force increases. But whenever that same simple pendulum, simple harmonic oscillator moves from equilibrium position to the other extreme position, the restoring force will gradually decreases. So it gradually decreases. Restoring force gradually decreases. ఇక్కడ ఫోర్స్ రెస్టోరింగ్ అని రాసుకో. ఇక్కడ ఫోర్స్ రెస్టోరింగ్, హియర్ ఇంక్రీజెస్, హియర్ డిక్రీజెస్. Here oppositely there exists some force acts, that is called resistive force. So here, okay, up to here clear. I will explain after rubbing this one. Okay, yes. Copy this one. Next, what is this one? Resistive force. What is resistive force? Resistive force. So, what is automatically resistive force? Means the force which acts opposite to the direction of the motion of the body. That is resistive force. In mechanics, we can call it as when we discuss about the body, when our body is moving in forward directions, automatically some force will act against to reduce the or against the motion of the body, friction అంటాం కదా. In the same way here ఎలక్ట్రిసిటీలో రెసిస్టెన్స్ నేర్చుకుంటాం. ఓకే, ఎలక్ట్రిసిటీలో అంటే సెకండ్ ఇయర్లో వస్తుంది ఎలక్ట్రిసిటీ. సో ఇక్కడ ఆపోజిట్ ఫోర్స్, ద ఫోర్స్ విచ్ యాక్ట్స్ against the motion of the body is called resistive force. ఇక్కడ what is happening? So here some force acts opposite to this motion of the direction of motion. So e direction. So this is called F resistive force. This is F resistive. Here F resistive. So what is resistive force? The force which opposes the motion of the body is called resistive force. So due to the resistive force, automatically restoring force will be gradually decrease. Okay na? Due to resistive force, the restoring force will gradually decreases. So automatically what will happen whenever the force decreases? So displacement varies. How can measure displacement? The displacement is nothing but the distance from the extreme position to the mean position, that is displacement. Suppose the pendulum, the extreme position is here. So here what is the displacement? The displacement is nothing but the shortest distance from the mean position, to the pendulum, the position of the pendulum at that particular instant of time. Because why we are mentioning that particular instant of time means we can measure the displacement any time interval of time. Means suppose it reaches to this OA dash position. So this is the extreme position. Because one thing you have to remember, the extreme positions may not be same in each condition, in each oscillation, because the energy is conserved. In case of simple harmonic oscillator, energy is conserved. Means here what is happening? Potential energy and kinetic energy will be automatically converted from one form to another form. So sometimes potential energy converts into kinetic energy. Again kinetic energy converts into potential energy. So that the total energy becomes the same. So mechanical energy equal to what? Mechanical energy equal to potential energy plus kinetic energy. So total energy is nothing but mechanical energy. So this is to be the same. But what is happening? Potential energy and kinetic energy interchanged. Now it follows. Okay, but here energy is consumed. So because due to the resistive force, the restoring force decreases. Automatically force decrease means force into displacement is nothing but work done. Work done is stored as energy, potential energy or energy. So due to the reduction of force or reducing the decreasing the force, automatically work done will also be decreased. Due to decreasing of force, work done also decreased. So total energy also decrease. Okay na? So automatically the energy will be reduced. So energy reduced means because force decreases due to resistive force, means opposing force, due to resistive force, restoring force decreases. Restoring force decrease means energy decrease. Work done force into displacement, work done decrease. Work done decrease means potential energy decrease. Potential energy means here total energy will be reduced. So total energy reduced means energy is conserved. So after some time, so in the similar way, after some time, the means here whenever the energy is decreasing, means energy is conserved, automatically the oscillations made by this simple pendulum are called damped oscillations. What are damped oscillations? So for when a simple harmonic oscillator is making oscillations, due to the resistive force acts on the simple pendulum or simple harmonic oscillator, the resistive restoring force gradually decreases, and the energy will be gradually decrease. After some time the energy will be zero, means since force equal to zero, so automatically what is happening, the number of so the displacement gradually decrease, so the oscillations will be gradually reduced and force becomes zero, means energy will become zero and they will stop. So oscillations will be stopped, means no more oscillations, it comes to rest. So those oscillations are called what? Damped oscillations. Okay. Yes. So the damped oscillations are nothing but the oscillations are gradually decrease, comes to rest. After some time, the oscillations made by the simple harmonic oscillator will becomes zero, will be stopped. So those are oscillations are called damped oscillations. Okay, now. Yes, copy this one. Next 21 minutes. Next one, equation of the simple harmonic oscillator. Equation of the simple harmonic oscillator. See, what is the equation of oscillator? Equation of oscillator. Equation of an oscillator. How it will be? What is the equation of oscillator? F equal to minus k x power n. F equal to minus k x power n is the oscillator, equation of oscillator. So F is the force, means restoring force. K a number, any number, integer number. Okay. X displacement. N any integer, positive or negative integer, anything integer, an integer. Okay, now what is the equation of oscillator? Equation of oscillator is nothing but F equal to minus k x power m. Now what is happening? Displacement, if you consider the displacement, now this is the displacement. This is the displacement. Okay, now this is the displacement. Okay, now this is called x, this is called x. Okay, from here to here, both are same. Okay, now in the column. So displacement, suppose displacement, if you consider displacement, if two cases here arise, if n equal to, here integer means you can take a plus or minus values. If n equal to positive, take we can take n equal to even integers or odd integers. N equal to even integer. What is happening? What will happen? Even integer. If n equal to even integer, means n equal to what are, take 0, 2, 4, 6 and so on. So what will happen in this case? Equation becomes so F equal to minus k into x power 0, x square, x power 4. So what is happening? X is always positive in this case. Example this now. Okay, example. So F equal to minus k into x power 0, 1. F equal to minus k. Second example, f equal to minus k into x power 2. So f equal to minus k x square. So f equal to, in case f equal to minus k into x cube, x power 4. So minus k x power 4. So in all these cases f is equal to force is negative. That means the displacement is along negative x-axis. So that the displacement, this is, so the displacement is along negative x-axis. So this is positive 0 origin, this is plus x, this is a minus x. Okay now so here whatever it may be, the displacement may be positive or x may be plus or minus or whatever it may be. So for if n equal to even integer, the force is along the negative x-axis. F is along negative x-axis. Negative x-axis. Yes. Second case. If x equal to, here x is positive here. If x equal to negative, I am taking. X is negative means take this one. This is one case, case 1. This is case 2. Okay, another example. Okay now here what is happening? Suppose write example f equal to minus k into x power x is in case 2. Here x is positive. If x equal to negative, so minus x whole square. So minus x whole square means here minus k into x square. So f equal to minus. So even though x is positive or negative, total f equal to minus k x square. In this case also, if f equal x equal to x is negative, if x is negative, f equal to minus k into minus x whole power 4 equal to minus k x power 4. So f is always negative, even though whenever x equal to n equal to any any even integer, f is always negative, means along negative x-axis. So that means the oscillator, the body is not in oscillatory motion. Is not in oscillatory. కొంచెం డెప్త్గా ఓకే అర్థం వచ్చేసింది. ఒకవేళ అంటే ఫోర్స్ గురించి డిస్కస్ చేసుకుందాం. సో నెక్స్ట్ if what is the relation f equal to minus kx power n, case under case if n equal to odd numbers 1 3 5 and so on. So what is f value? Minus k into x is x power 1, so minus kx. So second example, f equal to n equal to 3 తీసుకుందాం. f equal to minus kx cube negative. In case x equal to negative, x value I am taking negative, means displacement negative. Is it possible to get displacement negative? Means whenever the pendulum is like this, take this displacement as negative, this displacement as positive. Okay na? So x displacement is negative means we are considering this side. X positive displacement, that means this is positive, that side, right side. Okay na? So x may be negative or positive. X may be positive or negative. Displacement is positive or negative in case of oscillatory motion. This is negative in this case. Okay na? Now in case of x is negative means this is this side, oscillator is left side along x. Force about force weight. F equal to minus k into x means minus x whole cube. So what is happening? F equal to minus k into minus x cube. Okay na? So F equal to plus kx cube. So force is positive. Suppose F equal to minus k x power minus x is minus. So F equal to minus k minus into minus plus k x power 5. So F is positive. In this case, the F is positive. So for odd numbers, odd integers, F is positive. It may be positive or negative. In case of even integers, F is always negative. Means along force is along negative x-axis. In case of n is odd integers, then x may be negative or positive. If you consider x value is negative or positive, then automatically F is sometimes negative, sometimes positive. Means restoring force is sometimes positive, restoring force sometimes negative. Means depending upon the position of the pendulum, either this side or means how do we say, whenever it is moving from the left extreme position to right extreme position, the force gradually, restoring force will gradually increase this side, gradually increase, so that its speed will be more whenever it is coming from this left extreme position to right extreme. Whenever it is reaching from this extreme position to right extreme position, mean position to right extreme, force, restoring force gradually decreases. So in this case, force reduces. In this case, restoring force increases up to here only. After that, whenever it crosses the mean position, automatically restoring force will gradually decrease, so that it becomes rest. Means force will becomes zero at other extreme position. So this is about the restoring force in case of minus plus, means sometimes here increases, restoring force increases. Okay, here restoring force decreases. Okay, yes. So automatic energy will be very consumed. So automatically what is happening? Energy is conserved. Okay, energy will be consumed. So automatically oscillations will becomes zero, because force becomes zero, means energy becomes zero. So these oscillations are called damped oscillations. So this is about what is this force called? Restoring force. This force is called restoring force. Okay na? When in this case the force is positive, this force is called restoring force. Now what is copy this one. Okay na? Now, so this motion is called simple harmonic motion. Now this motion is called simple harmonic motion. Simple harmonic motion. SHM. Okay. Now, okay, copy this one. Next, definition of simple harmonic motion. Next, definition of simple harmonic motion. Definition of simple harmonic motion. Definition of definition of simple harmonic motion. Definition of simple harmonic motion. See here, what is happening? F is this is the equation. F equal to minus k x power n. So here force acts on a simple harmonic oscillator. That force tends towards the mean position, means the displacement is directly proportional, the force is directly proportional to displacement and is opposite to the direction of the force. So the force. So the force, restoring force or torque, acts on a body, about its equilibrium position, about its equilibrium or mean position, is directly proportional to the displacement, is directly tends towards the mean position and directly proportional to the about its mean position, and the body tends to the acts on the body tends towards the mean position, tends towards the equilibrium or mean position, and directly proportional to the displacement, in opposite direction. Opposite means force is directly proportional to the displacement, opposite direction. Displacement opposite direction. Then the body is said to be in simple harmonic motion. Okay, this is about simple harmonic motion. Okay, so I saw the message. Somebody asked about the artificial satellite. What about the time period of the time period of a body in a artificial satellite? Okay, na? Adi very topic actually. So before going to discuss about artificial satellite, we have to know about the gravitation time period. Okay, so gravity of the artificial satellite, all of then only you can understand you can understand the time period of the oscillator. So but I will explain this time, but we are not just we are in the starting of the simple harmonic motion. Okay na, but artificial satellite is another topic, but I will explain this time. So for time period T formula, time period T equal to 2 pi into square root of L by G. Time period T equal to 2 pi into square root of L by G. Okay na? T equal time period, L is equal to length of the oscillator. Okay na? G acceleration, gravitation force, acceleration due to gravity of the planet. Here we are considering artificial satellite. Artificial satellite means whether is it having any gravitational force? No. For artificial satellite, no gravity. So no gravity means G equal to 0. Becomes 0. Okay na? So it becomes 0 means L by 0, infinity. One something by 0, infinity. Okay? T is infinity. So for artificial satellite, what is the time period? Infinity. So for a more explanation, you can contact this number I am giving. You can contact this number 94917 01652. 94917 01652. You can for any information. If you want any chapter wise, I will explain. For supplementary batch, I will explain. So this time, if anybody want the explanation, any topic, any chapter, I will explain. So you can contact to this number. Some they collect some fees. The fees may be through phone pay number. This is the okay. By paying fee to this number 94917011652 phone pay. So whatever the chapter you want, I will explain definitely. Okay, whatever the chapter you are having any doubt or any questions, any chapter, I will take online classes for you. Okay, what this one 94917. Okay, thank you. Once again I am writing 94917011652 phone pay number. For any more inquiry also, you can contact and get information or any chapter if you want to know. I will take online classes and you can pay the money fee by phone pay to this number. The fee structure. Okay, thank you.